Um, that's a little jarring, sorry. Why we want to use it is it helps us organize our notes a lot easier using just the metadata and no natural language processing that goes into the notes that increases the complexity of whatever you're doing. It's also used in HL7's clinical document architecture standard. And the way we use it is we map to 5 dimensions that LOINC is using that we will cover in the next slide. The 5 domains and dimensions include the subject matter domain, document type, the type of service, the setting, and the author's role. On the right is an example of how LOINC individually maps each entry for the role dimension to a code. And these are considered part numbers and parts. In this case, the parts are for the role. And you don't need all 5 to map to get a mapping. So at the bottom, you can see 3 examples. The first example has 4 mappings, while the last one has only 2. And we'll continue onward. And now we'll talk about how we mapped to the 5 dimensions with our metadata sources. So showed is a graphic of how Mizzou, led by Huzaifa, who is not here today, he led this effort in mapping their data sources to the 5 dimensions. As you can see, this just applies to a Cerner site, not Epic. MCW is Epic, but Mizzou is Cerner. But continuing on, this is how things looked for an Epic site. We have a lot more mappings from one data source into the same. So you can see in red two options for the subject, and that's department specialty or author specialty. There's also author service in there. And towards the bottom right, you can see that service, we only use 1, and the same for document type. For Epic, we're only using H&O notes, but that's still a couple 100 million notes. And the way we prepare things is we do not operate on each individual note itself. We just group the metadata together. So on the left would be what your normal table looks like with everything related to that note. But on the right is just the columns that we're concerned about, which is just the metadata, and we give an identity to those. So identity is 1 to 5. Each of those should be unique. Okay, and yeah, any questions so far before we touch on mapping directly to the LOINC codes? Okay, just comments about recording. So to map to the LOINC codes, what we use what's called bag of words to compare our notes metadata to LOINC codes. Our note metadata forms one bag of words, while the individual parts of a LOINC code make up the other. As you can see on the right, those are different sets of bags of words for different LOINC codes, while on the left, we have the same thing, but for our notes metadata. And we use a synonym list to cover matches that are slightly different, but should mean the same thing. As you see at the bottom right, on the right-hand side, it says diabetes to diabetology. There are some occurrences where we need that, including diabetes and OBGYN, which you'll see later. This is an example of how the different parts are brought together to form the bag of words. So as you can see, we have note, progress, outpatient, burn, and management. Each is a different word, although burn management is a phrase in this case. But that's one of the strengths of bag of words. We don't need phrases per se. And here is the metadata from Mizzou on how they got their 5 dimensions mapped to form their bag of words. You may not be able to see this in great detail, but each row represents one set of metadata. And this is an example of how we take one document's metadata shown at the top, turn it into a bag of words, number 2 in the middle, and then we have 3 options to map. For our algorithm, it takes the one with the most matches for each individual dimension. So the first one has the most, and the second one only has 2, while the third one also has 2. And as you can see, there are placeholders in here, role and setting at the top right. You can see those listed or anywhere inside the bag of words. Those are wildcards that we use because you don't need every dimension mapped. You just need at least two, I believe, to get a valid mapping. And here again, I'd like to reiterate that we don't do this process for each individual note, but the set of metadata. So on the left, you can see that the size of our sample decreases greatly when we're not looking at every note, but instead group them. And for Mizzou, it takes their set down from 132 million to just 289,000 rows, and you see similar results down below for MCW. Now on to the validation, which is what should be new to most of you. So to validate our program's performance, we took a random sample of 200 rows from our top 1,000 sets of metadata. That was arbitrary, but it did give us a decent size, a sample size to pick from. Using the number of nodes, Mizzou was able to get about 91.4% accuracy on 10% of their nodes, while MCW was able to get about 85% on 8% of their nodes. And we do have that broken down by rows versus nodes on the right-hand side. If you'd like to look at this later, you can. Things did not always look as you saw in the previous slide where it was 85%. We have done multiple iterations of validations that have highlighted some issues that we've resolved that it's improved our performance. So the first round was basically a coin flip. And that was just our first run. We got things just pushed out. The second round, we worked on getting rid of some undesirable document types, which is mostly scanned document. And after that, we started looking at things that weren't recognized by LOINC, such as OBGYN as a phrase itself. Instead, it needed to be obstetrics and gynecology. And at the bottom, you'll see one example of an issue we're currently facing, which is some words or phrases mean more than others. In this case, it would be the word surgery. While the subject is vascular surgery, the LOINC mapping goes towards operative notes because of surgery. And you can see that it ignores the document type where it's clearly a progress note. And here is another example. Both of these are valid mappings. And I guess I should touch on that. What I mean by valid is, was it a good mapping or at least decent? We considered that valid. If it was off and just simply wrong, it was invalid. I have also grouped together what we were unsure about into the invalid group. If we were sure about it, we just left it as valid. Otherwise, it's invalid in this case. Let's see. Yep. Yeah, so these were two mappings that were good. And as you can see, I've highlighted the OBGYN issue that's now been resolved. So we get those mapped successfully. The other above is just a typical one that we have run into a lot, just a telephone encounter or a telephone note. And here we've started rolling things out to other sites as you've seen before on your GPC dev call meeting, that agenda. We have about 4 sites in the process of data collection and 5 more queued to start. Eventually we'll have more validation done, but we're currently focusing on just getting the data extracted and running the script on it. Turnaround time for this is it ranges from a week to a month, depending on people's schedules, but that time frame seems to not be mostly impacted by the script and the process of getting the data. It's just people are busy instead. And here are some results that we have. You've already seen the coverage, which is at least 85. It's at least 80% with no modifications out of the box for the other 2 sites that have done it so far. So UT Southwestern and Utah. And we can do simple things like break down what percentage of notes belong to whatever category. In this case, this is Utah's. We have a big chunk of it, or not big, but significant chunk that's not mapped. Those are none. And that's expected because these are Epic sites. So what they don't have is a document type. So while the document ontology tells you what the document type may be, if you don't have an idea of what it might be, it can't differentiate between a letter, a telephone note, and just a normal note. So those things we haven't added defaults. So those are all just not mapped. But as you can see, they have 79.8 million notes total. 8 million are not mapped, but their top 5 are listed there. And we've repeated this for UT Southwestern, who have 926 million notes with 21 million not mapped. And then once again, we have that for MCW, who have comparable number of notes, but 21 million not mapped. So almost the same thing at both sites. And that concludes my presentation. Do we have any questions?